Picture this, a universe so vast, so ancient, it's practically screaming with secrets and we're on the cusp of cracking its code. Is there life out there? Are aliens real? What happens when you fall into a black hole? And what even is time? These aren't just questions. They're the keys to unlocking the mysteries of existence itself. Buckle up, because we're diving into a mind-bending, heart-pounding exploration of the cosmos, where shocking discoveries, cutting-edge science, and raw emotion collide. This is the moment humanity's been waiting for. Proof of life beyond Earth might be just years away, and the universe is ready to spill its deepest truths. Let's start with the big one: life beyond our pale blue dot. The idea that we're alone in this cosmic ocean feels absurd when you consider the numbers. 2 trillion galaxies, each stuffed with billions of stars, many with planets that could cradle life. But it's not just about dreaming, it's about hunting. Right now, rovers are scraping the rusty surface of Mars, collecting samples that could scream life was here. Missions are zooming toward Jupiter's icy moon Europa, where oceans slosh beneath a frozen crust, teeming with potential. Saturn's moon, Enceladus, is spitting water plumes into space, practically begging us to check for microbes. These aren't sci-fi fantasies. These are real missions, happening now, with answers that could hit us like a cosmic freight train in the next decade. Imagine the moment we find a single microbe, a tiny speck of alien life. It wouldn't just be a discovery, it'd be a revolution, rewriting who we are and where we stand in the universe. The hairs on your neck are standing up. Just thinking about it, aren't they? But let's be real. Finding life isn't about stumbling across little green men waving hello. It's about microbes, the simplest building blocks of biology. Here's the wild part. Earth's own story hints that life might not be so rare. Our planet is 4.5 billion years old, and evidence of life pops up just 700 million years later. That's barely a cosmic blink. As soon as Earth cooled enough to have liquid water, life said, "Let's roll." This suggests something jaw-dropping. If you've got the right ingredients, water, heat, a pinch of chemistry, life might just spark like a match. So we're chasing those ingredients across the solar system, from Mars' ancient riverbeds to Europa's hidden oceans. The strategy is simple but electrifying. Go where the geology is active, where water flows or once flowed, and look. If we find even a whisper of life, it'll mean the universe is probably teeming with it. But here's the gut punch. Complex life, like plants or animals. That's a whole different beast. Earth took 3 billion years to go from microbes to multicellular life. If we find anything beyond bacteria out there, it'd be like winning the cosmic lottery. Now let's talk about something that makes your brain do backflips. Black holes. These aren't just space's vacuum cleaners. They're the ultimate enigma, warping reality itself. Picture a star collapsing into a point so dense, it punches a hole in the fabric of space-time. Anything that gets too close, poof, gone. But here's where it gets wild. Black holes don't just destroy. They might hold the secrets to the universe's deepest laws. Decades ago, a revolutionary idea shook the physics world. When stuff falls into a black hole, does its information, its very essence, vanish forever? The initial calculations said yes, sparking a paradox that had physicists tearing their hair out. If information is lost, it breaks the rules of physics as we know them. But the latest breakthroughs, hot off the presses in the last few years, suggest something mind-blowing. The information isn't lost. It's somehow encoded in the radiation that black holes spew out as they slowly evaporate. This Hawking radiation might carry the blueprint of everything that ever fell in, like a cosmic fingerprint. But how? That's where things get downright bizarre. Some physicists are tossing around ideas so wild they sound like sci-fi fever dreams. Picture tiny wormholes, tunnels in space-time, popping open inside black holes, funneling information back to the outside universe. These aren't the wormholes you'd hop through to zip across galaxies. They're theoretical bridges that might solve the puzzle of how information escapes. It's speculative, sure, but it's the kind of idea that keeps scientists up at night, scribbling equations in a frenzy. And here's why it matters. Cracking this mystery could unlock a deeper truth about reality itself, a theory that ties together the quantum world of atoms and the cosmic world of stars. Black holes aren't just objects. They're laboratories where the universe tests its own rules. Speaking of rules, let's tackle time. What is it? You feel it slipping through your fingers every day, but defining it is like catching smoke. In the best theory we've got, Einstein's relativity, time is woven into the fabric of space, creating a four-dimensional tapestry called space-time. Clocks measure your journey through this tapestry, ticking off the distance you travel from birth to now. But that's just mechanics. The real question is, what's time made of? Why does it flow one way, from past to future? The answer lies in a concept so profound, it'll make your heart race: entropy. The universe started in a state of perfect order at the Big Bang, a moment of unimaginable density and heat. Since then, it's been unraveling, getting messier, more chaotic. That's entropy, and it's why eggs break but don't unbreak, why we age but don't youth. Time's arrow points toward disorder, and every tick of a clock is a step in that dance. But here's the kicker: we don't fully understand what time is at its core. Some physicists are chasing a radical idea that time and space aren't fundamental but emerge from something deeper, a quantum soup where the rules of reality are rewritten. Imagine a universe where beginning and end lose all meaning because time itself isn't real. This isn't just abstract philosophy. It's the frontier of physics, driven by studies of black holes and quantum entanglement. The same ideas that make quantum computers hum, where particles are linked across vast distances, might hold the key to what time really is. And if we crack that, we might finally answer the ultimate question: did the universe have a start, or has it always been? Let's zoom out to the big picture. The universe itself. It's 13.8 billion years old, a number we know because we've measured the oldest light in existence, the cosmic microwave background. This faint glow captured by satellites is a snapshot of the universe just 380,000 years after the Big Bang, when it was a hot, soupy mess. Before that, light couldn't travel. It was trapped in a plasma too dense for photons to escape. So we can't see further back with light, but we're not giving up. Neutrinos, those ghostly particles or gravitational waves, ripples in space-time, might let us peek closer to the Big Bang. Every discovery pushes us closer to understanding how this all began, and whether began even makes sense. Now let's talk aliens. Not the Hollywood kind with spaceships, but intelligent life out there in the galaxy. Here's the sobering truth: we don't know if they exist. The universe is so vast, it seems impossible we're the only ones, but the numbers tell a different story. In our galaxy alone, there are maybe 400 billion stars, many with planets. Yet when you crunch the odds, factoring in how long it takes for life to evolve, for intelligence to emerge, for civilizations to survive without wiping themselves out. The result is humbling. Some estimates say there might be just a handful of intelligent civilizations per galaxy. Others say zero. Zero? That's not pessimism, it's math staring us in the face. But here's the flip side. If we find even one other civilization, it changes everything. It's not just about them, it's about us, our place in the cosmos, our future. The search for extraterrestrial intelligence, SETI, isn't just science, it's a quest for meaning. And the tools we're using? They're straight out of a dream. Telescopes like the James Webb are scanning distant planets for signs of life. Gases like oxygen or methane that scream, "Something's alive." Radio dishes are listening for signals, any blip that says, "We're here." Meanwhile, quantum computers are revolutionizing how we process this data, untangling signals that classical computers couldn't touch. These machines aren't just fast, they're rewriting what's possible, harnessing the weirdness of quantum entanglement to solve problems that once seemed unsolvable. The same tech that's hunting for aliens is also probing black holes, decoding time, and unraveling the universe's birth. It's all connected, and we're living in the golden age of discovery. But let's get emotional for a second. Why does this matter? Why should you care about microbes on Europa or wormholes in black holes? Because this isn't just about science, it's about us. Every discovery is a mirror, reflecting who we are, where we came from, where we're going. Finding life beyond Earth would be like meeting a long-lost sibling, a reminder that we're part of something bigger. Understanding black holes or time isn't just for physicists. It's for anyone who's ever looked at the stars and felt small, yet infinite. These questions about life, about reality, aren't abstract. They're personal. They're the ache in your chest when you wonder what it all means. And here's the most shocking part. We're closer than ever to answers. The next decade could bring proof of alien microbes, a new theory of time, or a breakthrough in quantum gravity that rewrites physics. But it's not just about the destination, it's about the journey. Every mission, every equation, every late-night debate among scientists is a step toward truth, and you're part of it. By caring, by wondering, by watching this, you're joining a species-wide quest to understand the cosmos. So let's keep looking up, keep asking the big questions, and keep chasing the truths that make our hearts race. The universe is waiting, and it's got stories to tell. Now imagine the stakes. If we find life, it's not just a headline, it's a seismic shift. Governments, religions, philosophers, everyone will have to grapple with what it means. Are we special, or just one of many? If we crack the black hole paradox, we might unlock technologies we can't even dream of. Ways to bend space, manipulate time, or harness energy beyond imagination. And if we figure out what time really is, we might finally understand our place in eternity. These aren't just possibilities. They're probabilities, rushing toward us like a supernova. Let's circle back to the search for life, because it's the thread that ties it all together. The missions to Mars, Europa, and Enceladus aren't just about science, they're about hope. Every sample we collect, every plume we analyze, is a chance to answer the question that's haunted us since we first looked at the stars. Are we alone? The data is piling up, and it's electrifying. Mars Perseverance rover has already stashed samples that could hold traces of ancient life. Europa Clipper, launching soon, will dive through plumes to sniff out organic molecules. Enceladus's geysers are practically shouting, "Check me out." These missions aren't cheap. They cost billions, but their value is priceless. They're our ticket to a truth that could unite humanity or shake it to its core. And don't forget the bigger picture, the galaxy itself. Even if we find microbes, the hunt for intelligent life goes on. The Drake equation, that famous formula estimating communicative civilizations, is both a guide and a taunt. It reminds us how many variables, star formation, planet habitability, life's emergence, intelligence's rise, civilization's survival, have to align perfectly. Yet with 400 billion stars in the Milky Way, even a tiny chance means we might not be alone. The Fermi paradox, the eerie silence where we'd expect signals, looms large. But it's not a dead end. It's a challenge. Maybe civilizations are rare. Maybe they're hiding. Or maybe we're just not listening right. The latest SETI projects, powered by AI and quantum computing, are scanning the skies with unprecedented precision. If there's a signal out there, we're closer than ever to catching it. Now let's dive deeper into black holes, because they're not just cool, they're cosmic Rosetta Stones. The information paradox isn't just a puzzle, it's a clash between two pillars of physics, quantum mechanics and general relativity. Quantum mechanics says information can't be destroyed. Relativity describes black holes as space-time traps. The paradox arises because early calculations suggested that when a black hole evaporates, the information about what fell in is gone forever. That's not just a math problem, it's a crisis. If information can be lost, our understanding of reality crumbles. But the latest research, driven by geniuses wrestling with equations, points to a solution. The information escapes, scrambled but intact, in Hawking radiation. How it gets there, whether through wormholes or some other quantum trick, is the holy grail of modern physics. This isn't just academic. Solving the paradox could lead to a theory of everything, uniting quantum mechanics and gravity. That's not just a trophy for physicists, it's a game changer for humanity. Imagine technologies that manipulate space-time, energy sources that dwarf nuclear power, or insights into the universe's birth that make today's science look like cave paintings. Black holes are our guides, and they're talking, if we can just decode the message. Time, too, is more than a ticking clock. It's the heartbeat of the universe, and we're starting to understand its rhythm. The thermodynamic arrow, entropy's relentless march, explains why time feels one way. But it's not the whole story. Quantum theories of gravity, inspired by black hole research, suggest time might be an illusion, a byproduct of a deeper reality. This isn't just mind-bending, it's emotional. If time isn't fundamental, what does that mean for our lives, our memories, our dreams? The universe isn't just a place, it's a story, and we're characters trying to read the script. Let's not forget the cosmic backdrop, the universe's expansion. Discovered in the 1920s, it's the ultimate clue to our origins. Galaxies are racing apart, and the rate of that sprint tells us the universe's age, 13.8 billion years. But it's not slowing down, it's speeding up, driven by a mysterious force called dark energy. This isn't just a fact, it's a mystery that keeps astronomers awake, wondering what's pushing the cosmos apart and what it means for our future. Will the universe expand forever, fading into a cold, dark void? Or is there another chapter we can't yet imagine? Every measurement, every telescope brings us closer to the truth. And then there's the question of wormholes, not the sci-fi kind, but the theoretical tunnels that could connect distant parts of space-time. The math says they're possible, but stable ones require exotic matter we've never seen. The latest buzz, though, is about wormholes in black hole research, not as travel shortcuts, but as information highways. If they exist, they could be the key to the information paradox, linking the inside of a black hole to the outside world. It's speculative, but it's the kind of idea that makes your pulse race, hinting at a universe more connected, more alive than we ever dreamed. So, where does this leave us? On the edge of a cliff, staring into the abyss of the unknown, and it's exhilarating. The search for life, the mysteries of black holes, the nature of time, they're not separate puzzles, but pieces of the same cosmic mosaic. Every answer we find sparks 10 new questions, and that's the beauty of it. Science isn't about certainty, it's about courage, the courage to ask, to explore, to dream. And right now, we're dreaming bigger than ever. Imagine the day we announce life on Europa. Picture the headlines, the tears, the debates, or the moment we solve the black hole.